to save energy. It makes sense. It's also available for lead points. Again, looking at that energy pie chart, ventilation was a 10% number. So if you can cut that number down, there's a lot of energy savings to be had. Heat exchangers for exhaust air for, again, assembly areas make a lot of sense. Reclaim energy. Equipment efficiency. If you have a building that's 10 years old or older, the rooftop air conditioning equipment is probably really not that efficient by today's standards. Refrigeration plants for chillers have really improved in the last couple of years with dual compressor machines that when you're on one compressor, you basically double the surface area available for heat transfer. That really reduces the kW energy of the machine. Boilers. High-efficiency boilers are available now with condensing apparatus that allow a typical boiler for the last 50 years has been an 80% efficient boiler. And then with the fire tube boiler coming into play in the late 70s, the efficiency went to 85%. Typical condensing boiler has an efficiency of over 90%. It probably would make sense to take a look at your boilers. And does a condensing boiler make sense? The numbers might say it does. Geothermal. We heard a couple notes about geothermal here in Scranton. Scranton is sitting on a pool of mine water that is a great situation for heat reclaim. There are some issues with doing that as far as fouling of equipment, and that needs to be taken into consideration in the design. Geothermal now has some government-backed money available. Geothermal really is a winner. It makes a lot of sense. I know we have done a number of projects before the incentive plan came into play, and it makes sense financially. Water conservation, low flush toilets, metering of water in your building for reduction of your sanitary bill. If you're using water for your cooling tower, and it's really not going out the pipe down to the sanitary authority, metering of that equipment makes a lot of sense to reduce your bill. This one we heard a little bit about earlier, microturbines. I think that with the green construction that's going on in the LEED program, I think you're going to see a lot more microturbine. A microturbine really is nothing more than a small generator plant. Normally they're in the 65 to 85 kW range. It sits in your building. You hook up a gas line to it. It runs on different alternative fuels. You can put fuel oil into it. It only has one moving part, the turbine, and it gives off electricity that normally synchronizes right into the power company, and it also gives off heat. It makes a lot of sense. 50% efficient versus 25 coming out of the wall. Again, people have stayed away from microturbines because of the issue of first cost. Now there's incentive money available, and with the rate caps coming off, I think you're going to see them start to move. Combined heat and power is nothing more than a microturbine on a large scale. I know our team has studied the CHP plants for the past 5 or 6 years. We really, locally here in Pennsylvania, they don't make sense right now. I mean, power is just too cheap to put them in. However, that will change shortly. So combined heat and power, I think, is going to be something that a lot of industrial plants are looking at in the near future. Solar voltaic, photovoltaic, again, that's a technology that's available out there. It has not made sense in the past because of the payback. Now with the stimulus money available, it's something that needs to be reviewed. A lot of people in the room have generators in their buildings that are for emergency purposes. The power companies now have not really put generation in place over the last 15, 20 years with the problems with nuclear. There is a demand side problem in the country. The power companies are encouraging people to use their generators as a demand side reduction tool. If you talk to your local power company, normally they can structure a deal for you where you would turn your generator on during a high demand period and they would give you a reduction in your electric bill. That's pretty substantial. Building envelope, a review of the building envelope. Glass is probably the biggest issue on any building. Normally, glass in the wall provides 10 times the leakage of a standard wall section. So glass is an issue. Solar gain through glass is an issue. Shading techniques of trees outside for summer shading. In new construction, locating glass correctly. Providing shade such that the high summer sun doesn't give you indirect or direct sunlight, but trying to capture that low winter sun and get bounce in to reduce the lighting in the building. And thus, again, hopefully putting in daylighting controls on perimeter of the buildings to reduce the lighting issue. Thermal scanning of your building makes a lot of sense to find the energy leaks. That's good for both the wall and the roof. A lot of times you say, hey, you know what, I have a great roof. I have 3 or 4 inches of insulation up there. It works great. If that insulation gets wet, guess what? It doesn't work good. A thermal scan of your building will determine if you have those kinds of issues. Any questions on any issues you may have in any of your buildings on any systems?